In this video, we're going to be looking at an isosceles triangle. We're going to review a little bit about it and talk about how to calculate its area. So just an overview of the whole question. We have isosceles triangle ABC with base segment AC, and our goal is to find the area of triangle ABC. Zooming in a little bit more on the triangle so we can review what we've talked about so far. Remember, a triangle that's isosceles has a line of symmetry, so I drew that in pink. The line of symmetry, you can imagine it as a fold line. So if I folded the triangle in half, this leg that's 10 would match up with this leg that's 10. We talked about how the base angles were congruent. So if I folded over, angle A would land on top of angle C, and they are equal. Angle B is called the vertex angle, and what's happening here is that the line of symmetry separates the vertex angle into two smaller equal angles. So the vertex angle is bisected by the line of symmetry. At this point, the line of symmetry creates a right angle, so I'm going to add that into the diagram. And in addition, this is a midpoint. So the entire length here is 16. I'm going to label these each as 8. And let's add the letter M to reinforce that that point right there is a midpoint. So this right angle that I added to the picture is really important because perpendicular segments are needed to calculate area. The area formula is area is 1/2 base times height. Base is always perpendicular to its height. So if we go back to our diagram here, here is our right angle. One side of the right angle is the side that we're going to use as the base. And in this direction is the height. Now right now we don't have any information about the length of the height, so we're going to label that as x. We're going to take a few minutes to just focus on half of the diagram. If I look at the isosceles triangle, the line of symmetry, separates it into two right triangles. So what we are able to do is to use the Pythagorean Theorem, and that is going to help us work to figure out what x is. X is one of the legs of the right triangle, 8 is the other leg, and 10 is the hypotenuse. So, like we did in our other Pythagorean Theorem problems, let's do our arrow there. And we're going to write a squared plus b squared equals c squared. So one leg is x, the other leg of the right triangle is 8, and the hypotenuse of the right triangle is 10. Remember, the side that is across from the right angle needs to be C. A and B are the two sides that are connected to the right angle, and you could interchange the order of where the 8 and the x are. I like to lead with the x. So right here, 8 times 8, 64. 10 times 10, 100. I need to isolate x, so to undo the 64, use subtraction. My next step is to undo the exponent of 2 using the square root. And we are looking for a length, so we are going to focus on the positive answer, which is 6. Oops. Sorry. Moving back up to look at the whole picture, so what we just calculated right now, the length of 6 is the height of the isosceles triangle we're working on. So I'll write the 6 right here so we have it. Focusing now on this side, because remember our goal was to get the area. So we have a second calculation to do here. Remember, area, I need the base and the height. I'm working on the isosceles triangle, so for the base I'm going to use the entire length here of 16. And then the height is what we just found here, is 6. Some of my students prefer to write this way, 16 times 6, and then divide by 2. "16 times 6 is 96. Divide by 2 is 48. And this is in centimeters squared. Over here, when we got x, it was actually the height, and I could label that with centimeters. So backing up so you can see the whole process. Again, the isosceles triangle, it helps to review the parts so you can remember the relationships within the triangle. Pythagorean theorem is great because an isosceles triangle contains 2 right triangles. So we're able to use the Pythagorean theorem there. And then with that work done, we have enough information to go into the area formula, and 48 centimeters squared is the area of the entire isosceles triangle.